Yeah, it's okay. Yeah. So nice to meet you. I'm happy to be here this year. I remember when I was at Insomnihack for the first time as a speaker. It was in city center and university, really small area. And today we are here. I don't know how many hundreds of people are here, and it's really, really nice. So, yep, my name is Paul Rascagneres. I'm a threat researcher at Cisco Talos. So it's basically the threat intel team inside of Cisco. We provide threat intel on every Cisco product. So I normally mainly work on APT stuff. I work a lot on group 1, 2, 3, or if you were here yesterday, your intelligence spoke a lot about Turla Ouroboros. I work a lot on this topic and several other topics. So yeah, it's a picture of me when I have to reverse Delphi malware. I think if some of you already did it, you perfectly understand why I wear this kind of mask. So just before starting, few statements. This talk is about iOS and not about iOS. So if you are looking for a talk with an I in uppercase, it's not a good place. Sorry for that. I'm not an iOS expert. Yannick, I don't know where you are. I've got the light in my head. Yeah. So no, I'm not an iOS expert. I touched an iPhone for the first time 9 months ago. So I'm not really an expert. I simply have to investigate a compromised device, understand how it works, find the tool, understand the tool, and be able to do my work. And the presentation is more about sharing my experience, about all the fail I had when I tried, the stuff I discovered on iOS because I didn't know how it worked, basically, and stuff like that. So no jailbreak. I'm not part of jailbreak community. And yeah, so if you are disappointed, I think you have a few minutes to go on other rooms. No big deal. I won't be offended. But yeah, it's the purpose of my presentation. On the presentation, I will only speak of real malware I had to work on. So basically, I know malware on iOS does not exist, but I will present malware I really work on. Presentation agenda of the presentation. I will quickly speak about iOS architecture, so not in deep detail. I'm not here to explain you how works the kernel and stuff like that, but you cannot really understand how to analyze a compromised device if you don't have basic knowledge of how works iOS. I will speak about jailbreak because it's really a topic you need to think about when you have to analyze compromised device, because you will see the security put in place by Apple is really, really efficient, and it can generate issue from a forensic point of view. I will speak about the tool I use, the good one, the bad one, and we will see a few examples of how I use this specific tool. I will speak about malware deployment, and basically, in my cases, how the device was compromised, how the attackers deployed the malware on these devices. And finally, I will show you a few malwares, few video and stuff like that, because I got 1 hour, so I did some video. So, iOS architecture first. So, it's a Unix system. So, in an ideal world, you could have a shell. You can have all Unix command. You've got file system. And the design is a little bit the same than Unix. You have a kernel space, user land, and you have a lot of different framework, API. Some API can be used by iOS application developers. It's provided to help them to do their job. And some API are private and can only be used by the OS, for example, and stuff like that. So yeah, it's pretty common. Nothing really new in this design. The biggest difference, if you compare it to Android, for example, or a classical Linux system, is theoretically you don't have a root access. You cannot execute something with UID 0. It's normally impossible. You don't have direct access to file system, so you cannot list file on your file system. You must use Apple API to do that. And theoretically, you are not allowed to check what is in the file system. Every application has sandbox, so they run on their own environment and they cannot read, for example, the data of another application. You cannot say, I want to read this stuff on the file system. It's not possible. And everything is, on its own, sandbox. Another thing, it doesn't really change for forensic point of view, but the root file system is in read-only, so you cannot modify something on the root file system. It's not possible. But you have the same thing on Android if normally you have the same thing. And one of the most important part is the code signing. So you cannot run application if it's not signed, but you cannot run binary if it's not signed. So if by an exploit you are able to drop a file on the file system, if it's not signed correctly, you cannot execute this binary. So yeah, that's a lot of protection from a defense point of view. It's really interesting. It's really hard to jailbreak an iPhone. You need someone really skilled if you want to create your own jailbreak. So from security point of view, it's really nice. It's a huge work and really efficient. But from a forensic point of view, it can be a really pain in the ass to analyze some malware. I will explain you why and what kind of limitation I had due to this protection. So one thing is, should I jailbreak my device? So you have a device, you have a customer or whatever that give you a device, he explained to you, I know it's compromised for X, Y reason. And do you need to jailbreak this device to be able to work? So the problem is, with the current design, it's impossible technically to get the application if your device is not jailbroken. So you know this application is malicious. You can know this application come from this URL or whatever. Your customer can say, yeah, look, I know it's malicious, but in fact, you cannot help him because you cannot get the application. It's technically impossible. The application is stored on a file system that is not accessible, and you cannot get the IPA, which is the APK equivalent on Apple. You cannot make memory dump, and you cannot make disk dump and stuff like that. So in my case, I work on case where I was able to download the IPA on the internet. So in this case, I can download it and analyze on a standard phone. It's technically possible. But I've got other case where I didn't get the IPA file from the internet. So it was on the internet, but when I started the investigation, I got a 404. It was not online anymore. I know the application is here on my phone, and if my phone is up to date and I don't have any jailbreak, I simply cannot work. I need to switch off the phone and wait for the next jailbreak. It could be in 1 week, 1 month, 2 months, 6 months, or never. So it's one of the main issue I had is how to get IPA application from a device. If you can have the application from a website or whatever, how you can get it, you can analyze it without jailbreaking your device. For example, Frida, I will speak about this application later, works on jailbroken and standard phone. So if you have the application, you can reverse it, you can analyze it without opening your device. If you need to jailbreak your device, today there is 2 tools. Electra and Cover is probably the best choice because you can jailbreak phone up to 12.1.2 version. So it's it's not the last one, obviously, it's just before. And if the device is up to date, you don't have a lot of solution. You can ping Celebrite if you have a lot of money, or you can simply stop the device, change the profile to avoid automatic update and stuff like that. Typically, if I want to disable update, I set a TV OS profile. So I say to my phone, I'm Apple TV. And if it tries to update, Apple detects, no, you are not an Apple TV and don't do anything. So that's the best way to stop update on iOS. It's my way to stop update on iOS. Because since iOS 12, Apple implemented auto update. So if take care disable auto update if you want to freeze the device to analyze it later when a jailbreak will be available. One of the problem I have, as I said, 9 months ago when I tried to work on this case by accident, I didn't have a single iOS device. So I had to find iPhone, basically, or iPod or iPad. It's the same OS. You can use one of these devices or another one. I wanted a very specific version because I wanted a version I can jailbreak. So, and when you go on your Apple Store or supermarket, you cannot say, I want the old version, this one, because I want to jailbreak it. The best way I found, there's two ways, eBay, but it's crazy expensive. People make a lot of money by selling old version of iPhone. Or the other way is to get the serial number, and in fact, on the serial number, you've got the week where the device was designed and flash. And based on the week, you can guess the version of the phone. So here is an example, for example, of the website. So you put WW on this week manufacturer field, and you know it's probably more than probably 11.4.4. A pro tip: if you go in supermarket and you ask to the guy, "Can I see the serial number of the phone?" He's a little bit suspicious. And how I managed to have someone more easy with me, I simply say, I buy 2 phones if you let me do. And he gives me access to the serial number, because 2 iPhone it's a lot of money. So once you have your phone, you have the good version, you are lucky, you have the jailbreak application. So a jailbreak is simply an application. You install the application on your phone, you click on it, you wait, it's jailbroken, you have full access on the device. Today, all the jailbreak are non-persistent. So if you reboot your phone, you need to relaunch the application and jailbreak it again, because it doesn't change the file system to avoid breaking signatures, and your device doesn't boot anymore. So, if the purpose of my work was to analyze malicious application on iOS, so you have several tools to do those. So if you use IDA Pro, it works perfectly. If you have a license and you are used to use IDA Pro, it's not a problem. A less expensive alternative, but really with good output, is Hooper. And I think this one is €100, so it's pretty cheap compared to IDA Pro. And they perfectly support Objective-C or Swift code. So you can have this kind of output on IDA. So you can get directly the class name and the method name, etc. So if the developer doesn't put a lot of obfuscation, simply by looking the name, you can guess what the malware is doing. The tool I use the most on iOS investigation is Frida. It's an open source instrumentation framework. And he does a really, really great job. So I will show you some example how I use Frida in this context. The advantage of Frida is what I said. You can use it on jailbroken device. So you put Frida on the device and you say to Frida, I want to debug this application. It's the easy way. But if you don't have a jailbroken device, you can use Frida. You can take the malicious application, recompile it by injecting Frida inside of the application, and when you execute the application on your device, Frida will run inside of the malicious application you want to analyze. So it's really convenient from this point of view. You can see a lot of video on YouTube about how I cheat on this famous game by using Frida. So I found a specific class named WebDLNK, which means web download link. And in red, I don't know, yeah, you can read it. It's in fact the URL of the C2 server obfuscated. So in this case, the attacker doesn't put http mymaliciouswebsite.com, but put some obfuscation to avoid reading it really easily. So I will show you with Frida how you can manage this thing with maybe 6 lines of code. So, basically, I decided to attach my Frida session to this specific method, and I display the output of the function. Simply. Each time the function is executed, my code, my hook is executed, and I go at the end of the function, I display the output of the function. And you can see at the bottom here, each time I enter on this web download link method, I read the hightechmart.com website. So without understanding this algorithm, I can simply with Frida say, I want the output of this method, or this one, and understand really easily how the malware works. If you decided to be more stupid, you can do it directly by hooking URL requests from the iOS API. So instead of saying, I want to hook this method inside of this malware, I decide to hook directly iOS API and see each time the application perform request on a specific URL. And in this case, you've got the same thing on bottom. You've got the URL. So for me, today, it's the only really good tools for dynamic analysis on iOS. You don't really have choice. But Apple provides a debugger. So trust me, I'm a WinDBG user, and this stuff is unusable. So the syntax is very, very weird, and yeah, I had a lot of issue to use it. So it's native. It's provided by Apple. And in fact, when you use the official ID from Apple to develop your application, behind he uses this application, but it's hidden inside of the beautiful interface. And yeah, you can do the same thing, make some breakpoint and memory address and display the value. But finally, it was so much easier to use Frida than I didn't choose this debugger. Something really interesting with Frida, for example, if you go on my GitHub, I create a Frida script to dump the memory of my running process. So the advantage for me is I worked on the malware. I will probably explain it later, but I work on a malware that inject HTML inside of website. So the malware display a website and add JavaScript inside of the website. So you are on the real website, good URL, etc., but the malware inject JavaScript on the page. And thanks to this way to dump memory, I directly get the modify web page with injected code directly from memory. So it was really, really easy to get the modify web page directly by memory dump, by doing memory dump. So yeah, it works pretty well. If you have to work on this kind of case, and it works for Android too, for this specific slide, what I do, I have a dedicated hotspot at home, and this hotspot I create pickup, and I bind my device, my iPhone, on this hotspot. So I download all the pickup of my iPhone doing requests on the internet, etc. Of course, you can have HTTPS, and it's not really useful to have encrypted pickup. And in this case, I use Burp, and I make man in the middle. I trust the certificate, SSL certificate of my Burp server, and I dump every web request by doing man in the middle. So if you download Burp, you have a documentation about how to do that on iPhone. So you don't have to think, you simply follow the documentation. And it works really well. So I'm able to have pickup, I'm able to have HTTP, HTTPS, and generally it's good enough from a network point of view on a dedicated hotspot, because I don't want to add noise with my other device, basically. And potentially I want to use a VPN or stuff like that. So, malware deployment. So many lapses. In this part, it's basically how malicious applications were deployed during my investigation. But to understand that, you need to understand a little bit how you can legitimately deploy application on a phone. So, basically, there is not a lot of way to do it. An application must be signed. It's the rules. You cannot have Apple application on your device if it's not signed. During my investigation, I found several ways to sign application. You can sign it with an official certificate. You pay at Apple and you are on the store and you sign with this application. It's how it works all application. But it's not so easy to be in the Apple Store. You cannot develop the malware and put it on the Apple Store. It's a lot of work. I don't say it's impossible, but it's really not as easy as for Google Store, for example. Another way to do it is a developer certificate. So a developer certificate, I've got one, for example. It costs €100, so it's really cheap. And you can deploy application on a device, but you must manually trust this certificate. So the user must say, okay, I trust this developer certificate, and I install it on my device. At this time, you can install all the applications signed by this certificate. Another way it's used by developers too is to create a profile with UDID. So how does it work? You can say this application can be only installed on this specific device based on this unique ID. It's used a lot by developers. The developers have a lot of iPhone, every version, every model, every size of screen, etc. And they develop their application and put the serial number of all their phone and deploy it on all the phone and check if the font are aligned, if everything is beautiful and works correctly. And yeah, that's how they work basically. It's a really interesting feature from a developer point of view. We saw some malware deployed with these tricks. The attackers knew the ID of the phone. I will show you how. And signed application with the developer certificate dedicated to this phone. Here is, for example, a fake certificate, a developer certificate. So you must understand that this certificate was delivered by Apple, but it's not a production certificate, it's a developer certificate. You need to install it manually. So it's Cambridge University, but in fact it was in I don't remember, somewhere in Middle East, I don't remember who. In fact, it's not the Cambridge University at all, but they buy this developer certificate, sign malicious application with it, and here we go. Here is, for example, a profile including unique ID from a specific device. So it's simply a string with this ID, this ID, this ID, and the application can only be installed on this list of devices. If you try to install it on another one, it would say, no, it doesn't work. Here is, for example, a GitHub project to get the UDID of a user. So it's a web page that send, when the users go on this web page, it push a profile file. iOS interpret this profile file, ask to the user, oh, be careful, the website want to have information of your device. Are you okay? If you say okay, it will send the unique ID to the server. If you say no, of course, it won't do anything. Yeah. So it's nothing new extra. So another way, the most common way we saw last year during our investigation, is to use an MDM. So a malicious MDM, malware, mobile device management, I think, something like that. So if you work for a big company, I think and you have an iPhone, even an Android, but on iPhone specifically, you are probably already enrolled on MDM. So your company manages your phone remotely and is able to, I don't know, maybe wipe your phone if you lost it to avoid losing sensitive documents and stuff like that. MDM on Android and MDM on iPhone is completely different. On Android, MDM is basically an application, and you decide what you want to do. If you ask for all the permission, and you do, the application does everything. On iOS, MDM is not an application. it's part of the operating system. So you cannot choose which feature you want. The features are provided by Apple. Apple design the MDM and say, with the MDM, you can do that, you can do that. Here is the API to do that, etc. Nothing more, nothing less. It's provided by Apple, documented by Apple, and you don't need to develop your own application to be an MDM from a phone point of view. On Android, generally, you install a specific application, and this application is used to manage your phone by your company. So, how does it work? You would see, to be enrolled on MDM on Apple, you need a lot of click. But when I say a lot, it's a lot. Yeah, URL, be careful. The URL want to change your configuration. After you have the certificate, you say, okay, I want to trust this certificate. I want to install it. Yeah. So I think for the moment it's 4 or 5 click, and 6 click later, you are enrolled on the MDM. So in our case, we assume that the attacker had a physical access to the device of the targets. I can't really explain how, but we have some clue that the attackers had access to the device, had the PIN code, and was able to enroll the people. Because finally it's 5 click, but it's 30 seconds. So you can easily enroll someone on it. Something really interesting. So Apple didn't implement a way to remove application. So basically, if your company doesn't like this chat application you have on your phone, it's technically impossible for your company to remove this application. If it's downloaded from the store, it's your choice. Your company cannot remove this application. In our case, what was the goal of the attackers? It was to install fake chat application. For example, WhatsApp. So the attackers deploy a fake WhatsApp on the phone. So, 1 second. So the MDM asks to the phone, I want to deploy an application. And finally, the application will appear on your phone. Yeah, it's downloading. And here we go. You've got 2 WhatsApp. The real one from the store and the fake one from the malicious MDM. So the attacker is not able to remove the legitimate application because it comes from the store and it doesn't have any power against the store. How the attackers force the users to use the malicious application and does not use the real one? Here is you have 2 WhatsApp application, and I've got normally a refresh of my screen. Yeah, and if I come back, I only have 1 application. How the attackers do that? One of the features provided by Apple on MDM is you can set age restriction. And in our case, the attackers said, okay, this phone is limited at 9 years old. WhatsApp, it's 12. So the application disappears, but the fake application developed by the bad guys doesn't have any age restriction. So the only application that stays on your phone visually is the fake application. But the real one is installed. It doesn't remove it, but you cannot open it anymore. So that's how in this specific campaign, the attackers remove legitimate WhatsApp and let only the fake WhatsApp running. Yeah, just for the curious, you can see here how you can check your profile on your phone. Yeah, I've got 1 hour, so. Yeah, here you can see I'm enrolled on this specific MDM. And if I click on it, On the video, there is a lot of blah blah. Yeah, so you can see the malicious, the MDM, so maybe a legitimate one, maybe a malicious one, and you can see apps with the number 1. I've got a WhatsApp installed by this specific MDM, and if you check on restriction, you can see I got a app rating on false restriction. That means it's age restriction. If I go on the restriction menu, I can see it's limited to application lower than 9 years old. Yeah, just here you can see apps 9. So every application for more than 9 years old will disappear from your phone, basically. Yeah, that's how the attackers did this job. Okay. Another way to deploy application, if you're really rich, you can have 0-day or call Zerodium and use your money to do so. But on the case I work on, they didn't need that. They simply have access or do social engineering or whatever, but they don't have to spend a lot of money on 0-day and magic stuff. So now I speak about deployment. I'm going to show you a little bit how works the malware I work on in these investigations. So first thing, some application can be encrypted. So it's provided by Apple. It's the DRM stuff. But if your device is jailbroken, you can use BF inject to decrypt application. So basically it's encrypted, but it's decrypted in memory. BF inject reads the memory, don't extract the unpacked decrypted application, and you can analyze it. So it's never an issue, to be honest. So here is the 3 common techniques I saw last year. The first one is the library injection. I will show you exactly what it is. The second one is a WebKit interception. In this case, the attackers add JavaScript inside of web page and intercept in JavaScript what you are doing. And the last one, I will show you how works keylogger on iPhone, because you can develop keylogger for iPhone. So the library injection, basically you take an app and you recompile it with your own library, and this library will be injected in the app, and you put some hook on the function you want to intercept to get value. For example, that's what happened on the fake WhatsApp application. As you can imagine, the developer didn't develop WhatsApp from scratch. He took the application, used the library injection, inject his code inside of the WhatsApp application, hook on several functions to be able to get your contact, because the WhatsApp application have access to your contact, get your chat history, your pictures, because WhatsApp you can share pictures. So if you allow WhatsApp to share picture, the attackers have access because he's inside of the application. So if you allow the application, you allow the malicious code to get the data. He was able to get information on you, your phone number, etc. It seems to be useless to support injection like that, but today Apple supports it, and it's used massively by the Tweak community. So it's basically people that modify legitimate application to add features. I spend a lot of time looking at the application from a lot of Tweak community forum and stuff like that, and all the time it's not malicious. All the application I analyze from this community simply add feature, because I don't know, you have a chat application that does not support GIF. So they tweak the application to support GIF. WhatsApp, you can only have one account on WhatsApp. It's based on your SIM card, so you can only have one account. And I saw Tweak application